to redo the problem, I'll just redraw the graph to some extent. If you recall, it kind of looked like this. And the only thing I think that we left off, we did not do asymptotes. Is that right? Or do we need to do intercepts?
No, we did the intercepts, so you just need to do the asymptotes.
Okay, so the horizontal asymptote, the HA, is always this number here. It's y equals that number 3, and it's the only one. There's only a horizontal asymptote.
Mm-hmm.
Okay, so there's nothing else to do there. End behavior comes from the following. You have to write two things. As x goes to infinity, and you want to think of that as going to the right. And as x goes to negative infinity, you want to think of it as going to the left. So it's like tracing the curve. It's like tracing to the right. As you go to the right, the graph approaches this y value, y equals 3. We say f of x equals 3 because we use function notation rather than y. We can see that it approaches this y value here. It just keeps approaching it, never quite getting there. Things like that.
Right.
Going the other direction is like tracing the curve going the other way, and you can see that it goes up, and it ends up going up forever. Up forever is the y value of infinity.
Mm-hmm. Got it.
And I think that will do it for closing out question 5.
All
Let me
right.
know when you got that down. We can move on to 6.
Yeah, I'm ready for 6.
Okay. So for 6, we're going to start with a t-chart like we did in the previous problem. T
Mm-hmm.
just meaning that you have x and then f of x or y values. The instructor is very clear. Hey, you've got to use these values here. These are not always the best values, but we're going to go with them because that's what they want. Rather than writing a 0.5, I'm going to go 1/2 to the power of x minus 1 like this, just to
Okay.
make it a little bit more clear when we do this. Now, we start by putting -2 in for x. So that's 1/2 minus 2 minus 1. That's 1/2 to the minus 3 power. Okay. And there's all these exponent rules that we could go through. For example, the negative in the exponent causes the fraction to flip, and then it changes it to a positive exponent. And then the 3 gets distributed to both the top and the bottom, which becomes 8/1 or 8. Okay, so that first value is 8. Now, having said all that, you kind of got to decide, okay, I'm going to use the calculator, or I really want to do these by hand. At some point you're just like, well, it's just too much for me to do every time. We can do all the calculations by hand, or you can go to the calculator and calculate the remaining ones here. Kind of up to you. Just be careful though that your exponent, you get that right. Make sure it's in parentheses. Could you go to the calculator though, or by hand and do the next one for -1?
Yeah. Just give me like 1 second.
Yep, take your time. It's good practice here. Get kind of warmed up for the day.
Yeah. I got 4.
Yep, that is correct. Keep going for the next one.
So for the one with 0, it would be 2.
Good. So the next one will be 1. And I want you to notice this now. Do you see that there's a pattern to how the numbers are going down?
Yeah.
You're dividing by 2 each time, or if you prefer, you can think of it as multiplying by 1/2. Where's the 1/2 in our equation?
it's where's the 1/2 in our equation? Oh, it's in the
Yes.
parentheses.
Yeah, it's the base. It's the base. And I don't have the previous one up to show you, but you would actually notice that in the same one as well. The base tells you what the change is in these y values. So yes, you can go to the calculator, but you can also sort of pattern it. You can see that the next one would be 1/2 there,
Mm-hmm.
right? So next thing to do here is to graph it. Could you open up Desmos graphing calculator and graph this? And I will do the same.
So how exactly do I graph this again? Because I forgot a little bit.
Yeah, so the parentheses are really important. It's got to be a y equals, and I
Obviously.
like to put the base in parentheses, and the exponent has to be in parentheses the way that the calculator works. Otherwise, it won't um, won't graph what you want, basically.
Yeah.
Say it that way.
So I would do 1/2 to the power of 8 basically for the first one, right?
You graph with variables, so it has to have an x in it. You always go back to the original function to graph.
And man, this was graphing is a little bit of a challenge, but it's okay.
Right. So the difference is you're calculating the entire graph for all the points versus a single point.
Mm-hmm.
All right. So do you have that graph up?
Yeah, I do.
Okay. So it should look something like this. What does the graph appear to approach down here that I'm drawing in black? What would be the equation of that line? Y equals what?
Y equals um I don't know really like 0.
0. Yeah, it's the x-axis.
Oh yeah.
Right. And just like the previous problem, is there anything being added to the equation over here? Is it besides +0? Right. +0 just adds nothing.
Yeah.
And this number off to the side is always the horizontal asymptote. It's always the equation that the graph approaches.
Mm-hmm.
Okay. So you want to graph these points on there on your graph, or maybe label them. Some are easier than others. You can just sort of estimate the ones that aren't, perfect, but get a few of those graphed. Sometimes they like to see the ordered pairs on the graph. Just depends on the instructor.
Mm-hmm.
Something like that. All right. From here, we have to calculate a few things, the domain and range. So the domain, no change, right? Domain is -infinity to infinity. That's been the same in all the problems we've done. The range, though, the range is actually based on the horizontal asymptote, okay? It's either 0 to infinity or -infinity to 0, which we've not seen yet. So this first number always comes from the horizontal asymptote in the range. And it's because the y values go from approaching 0 to going all the way up to infinity.
Mm-hmm.
All right. Next thing it asks for are asymptotes. So you have to look for two of them. It's first, does it cross the sorry, not asymptotes, intercepts. Does it cross the y-axis?
Yes.
Okay, where does it cross the y-axis? What is the ordered pair there?
0, 2.
0, 2. And then does it have an x-intercept? Does it cross the x-axis?
No.
No. So we say no, no x-intercept.
Okay.
Last thing we can talk about is end behavior. So we have two things to write. As x goes to infinity, does that mean x is going right or left? You're going to the right, going to the left.
You're going to the right.
To the right. So we add, like we imagine tracing the curve. You're going to be driving soon. Imagine you're driving to the right. What y value are you approaching? Y value.
Negative. Wait, it's to the right. So I don't.
So the right's going to infinity, but what's the y value? The y values are the verticals. What's the vertical value here?
Negative 1, 4.
-1 is down here. It's not. What is it approaching? What is the horizontal asymptote?
It's just. I don't know. Now that I'm confusing myself.
So it always approaches the horizontal asymptote.
Right.
Like when you fly in a plane, I mean, it doesn't descend this quickly, but imagine it's lowering, lowering, lowering. It doesn't go below the ground. It touches the runway and you're there. This
Right.
thing is approaching y equals 0, and f of x is 0.
Oh, oops. I was just hearing
So
some things I got
so
lost.
if you say a negative value, you're saying it also that it crosses the x-axis. And you told me earlier it does not cross the x-axis.
Right.
Now let's go the other direction as x goes to negative infinity. That's like tracing the curve to the left. You're tracing the curve backwards. What's the y value? How far up vertical does it go?
I was about to say 0 again.
This goes up to 0.
No.
I mean, look where my cursor is. It was 2 and now it's 4.
It goes up to like 0. It goes up like infinitely though.
Exactly. Yeah, it goes up forever. So this is your end behavior. It's tracing the curve. It's tracing the curve to the right, tracing the curve to the left.
Mm-hmm. Okay, got it.
All right. So for number 7, kind of a rinse and repeat situation, you got to do the same thing again. They're really emphasizing this graphing here. So we're going to start with a t-chart, x, and then j of x, which is really y, -2, -1, 0, 1, and 2. I'm just going to rewrite this slightly, -2 parentheses 3 halves to the power of x. Will you calculate very carefully each of these y values for us?
Sure. Do you want the answer in decimals or fraction form?
Fractions, please.
Okay, so for the -2, I got -8/9.
-8/9 like that. Okay, keep
Yeah.
going.
-4/3 for -1.
Okay,
-2 for 0.
okay, keep going. Doing great.
-3 for 1.
Okay, and for 2.
-9/2.
All right, awesome. Okay, so a little bit tougher because there's the fractions. Now, if you multiply -8/9 by 3 halves, do you believe that you will get -4/3?
No.
Go ahead and try that then. -8/9 times 3 halves.
So I put -8/9 times 3/2 in the Desmos, and it's not giving me an answer. Like I might have done something wrong.
Okay, let me snip in what I hope you have typed. You do want two fractions. You want fraction 1 -8/9, and
Yeah.
then fraction 2 is 3/2. So you want something like this in your calculator here. Is
Yep.
that what yours looks?
Yeah, that's what mine looks like.
Okay,
But
so there's a button on the right for converting to a fraction.
mhm. Well, it's not showing me. That's just showing me that there's a. I don't think the for some reason doesn't understand why the multiplying or something. There we go. Now I got -4/3.
Perfect. Yeah. So this is how I'm checking it, by the way. I do calculate one of them, but then the next one, I'm multiplying by 3/2 and making sure that that's equivalent to what you've given me. And then I do it again for the next one. And then I do it again for this one. And where does the 3/2 appear in your function?
I'm sorry, what?
Where does 3/2, where does 3/2 appear in your function?
It appears in the for the j of x value, like
Okay, so this is called the base.
it appears in our base.
Yes. And is that the same as where the multiplier appeared in the previous problem? Did the multiplier appear in the base?
Yes.
Yes. And that's always the case. It's always there in the base.
Mm-hmm.
Okay. If you could graph this again,
Okay.
let me know what you come up with, what you see once you graph it. Should look a little different than usual.
It's just a straight line.
It's a straight line. It should have some sort of a shape to it. So double check that you've actually entered it the way that it's written. It's got to have an exponent of x.
Oh, that's the reason why it doesn't look correct. So the exponent of x will go for the 3/2, right?
Yes, you can. The nice thing is you can type it exactly the way that you see it. You don't have to make any modifications. It should look exactly the way that it's written with the x kind of up there. It doesn't really look like it's an exponent in the actual graphing thing, but it is. I mean, you have to sort of trust it. I mean, I wish it was a little higher on there, but so do you see a graph that looks something like this?
I'm working on it because I'm trying to get the exponent. I don't know what to write for the exponent. Do I write -8/9 or do I just keep it -8/9 times 3/2 with an exponent?
You always graph the original with the variable. Has to have a variable in it.
Okay.
The
Because
variable is x. It should look just like what's here, kind of showing with my cursor. That x though is, if there's an A to the B button, that's what you want to press to get the exponent. Or if you're using a Windows, Shift 6 to get the caret.
this this is annoying for me because I'm graphing it correctly. It's just that I'm not getting a curve. I'm not getting anything.
Okay. Um,
It's just a straight old line.
all right, let me show you here on the screen. Because you were able to do the other ones. This one really isn't any different other than it's different numbers. So I've got my screen up. Hopefully you're seeing that now. There it is. Okay. So we're going to type in y equals, okay,
Mm-hmm.
-2
Yeah.
parentheses. Now, if you need to, you can hit the division for the fraction bar. That's 3/2. Now, if I put, is this what you're seeing right now? A horizontal line through?
Yeah, and when I put the
Okay.
exponent in it, it's still a horizontal line.
Okay. So did you hit the A to the B button next? A to the B, and what you'll see is the cursor moves, and then you can put an X there. You've got to hit this A to the B button for the exponent.
There we go. Now it's curved.
Okay. All right. Go back to the other screen. So is there anything being added to the function? Is there anything being added over here to the right?
No.
No. Again, it's a +0. And what have we said a couple of times now about this value? What does it represent?
1.
Oh, you said 1. Let's go back and look at the previous problem here.
Sorry.
The +0, right? +0
I was thinking of
is
the
the
y.
horizontal asymptote.
Yeah. I was thinking of the power of 0 for some reason. I don't know. This is it's great.
Okay, so this one again has a horizontal asymptote of 0. And if you want to, you can think of it like when you land, it always approaches that. You approach the runway, or you kind of a soft, gentle, this one's upside down, but you can see that it approaches but doesn't quite ever touch that value. It never crosses. Never crosses.
Right.
The blue never crosses. Okay. So the next thing we can talk about from the graph is domain, and range. What's the domain for every problem we've done?
What's the domain for every problem? Okay. The domain is always negative infinity, comma infinity.
That's right. It's all real numbers. There's no restrictions.
Okay, and for the range, it's
For this time, you have to decide how far down, what's the smallest y value? How far down does this go?
well, I'm pretty sure, but it goes down like it would be negative infinity.
Yes, yes. So the range is always min to max. So now and I never really understand why this is visually unclear, but like how far up does the y go? Well, it stops getting bigger because it's always approaching 0. It's always approaching 0, but it never crosses 0. So 0 is the biggest number that it can be.
Mm-hmm. Got it. So next would be the intercepts, right?
The next would be the intercept. So you got to look here. Where does it cross the y-axis? What's the y-intercept? And I'd like it as an ordered pair, please.
It would be 0 comma -2.
That's correct. And then does it have any x-intercepts? Does it ever cross the x-axis?
No.
No, so we would say none. And then the last thing is end behavior. End behavior. This is where you traverse or travel the curve on the curve, left and right. So you start by saying, okay, as x goes to infinity, imagine you're tracing the curve to the right. What does the y value approach?
It approaches positive infinity, right? No, negative.
Yes. Negative infinity. Yeah. F of x approaches negative infinity. And as x approaches negative infinity, as you go to the left, what does the y value approach?
It would still be negative infinity, right?
Well, the x goes to negative infinity, but what is the y value at all these points? What is it getting closer and closer and closer to?
Positive infinity.
So that means it's up here above the x-axis is what you're saying.
This infinity stuff is still confusing to me.
So you
Um,
got to you got to change whether you're looking at the left going left or whether you're looking at the y value.
it
Are
would
you
go
looking
to
for
0.
it goes to 0? Yes. And full disclosure, most students really struggle with this. This is not a concept that's well understood. And
I still don't understand it.
well,
And
you're
I
doing better. You're doing better. I mean, it's really difficult because you've got to say, okay, I'm going left, but what is the other thing approaching? It's like my left hand's doing one thing. What's my right hand doing? And it's
yeah, no, it's just a mix of too many things. Anyway.
all
No.
right. So that takes care of number 7. 2 more graphs, and then the I don't know, the application problem. So, all right, here we go. Number 8. So this one, x, g of x, which is really the y, -2, -1, 0, 1, and 2. On your Desmos scientific calculator, are you able to find the E button?
Yes.
Okay,
Isn't
I
it in
want you to
functions?
say that again.
Isn't the E button in functions?
It is. You can also just type E if you're not excited about it. I believe it's EXP. But I would just use E. You can actually type in, for example, first one, -E to the -2 power.
Okay.
And this one will be a decimal, so let's round it to like 3 decimal places.
So it'd be like 0.135.
Good. Let's do the next one.
It would be 2.718 for -1. -2.718.
I'll try again. Like you've got maybe you didn't get the number in the exponent.
Oh, there we go. Okay, now it would be 0.367.
8 if you're rounding to 3 decimal places. And
Yeah,
go ahead for the next one.
368. I'll just round it. It would be -1 for 0.
Good.
Now this one would be -2.7.
Good.
2 point like 7. Yeah.
Okay. For the last one there.
Yeah, don't worry. Okay, -7.389.
Good. Okay. Now, when you graph this, it's y equals -e exponent x. It has to have an x in it. Cannot be a number. It has to be an x. Will you attempt to graph that for us, please? And let me know what you see when you graph it.
Okay, it curves. It starts
Yes.
curving around where 1 is.
So it kind of looks like the last one.
Yeah.
Is there anything being added to the right here?
No.
So +0 again. Do you remember what this value represents? The value of +0. What does it represent on the graph?
How do you say the y-axis? It's the y-axis, right?
X-axis, y equals 0. It's the horizontal asymptote. And actually, we didn't do the asymptote in the last one. Is y equals 0. I just realized that.
No, we did. I wrote it down.
Oh, good. Yeah. Okay. So this one has a horizontal asymptote y equals 0. That means the graph approaches 0 when you're going this way. When you go in left, it approaches 0. Even though it's going left, the y value approaches 0. Okay. So let's talk about domain and range again.
Okay.
What's the domain? And
-infinity, infinity.
good. And how about the range this time?
-infinity and with 0 and comma 0.
Good. Really good. Okay. And we just mentioned the horizontal asymptote. It does have a y-intercept. You can see that from the graph, from the table and the graph.
Mhm. It would be like -1, sorry, not -1. 0, comma, -1.
Good, good. Yep. All right. And then intercepts, or I'm sorry, horizontal asymptotes got y equals 0 for the horizontal asymptote.
Yep.
You'll get to maybe vertical asymptotes in another lesson.
Sounds great.
All right. Awesome.
And
So
then-
the next thing here is end behavior. And so sometimes it's good to have that graph there. You can see that it kind of looks like this. So as x goes to infinity, as x goes to negative infinity. So the first one is as you go to the right, what does the y value approach go to?
as the x goes to positive infinity, it's 0, right?
As you go to the right. So imagine putting your finger on the curve and you're moving to the right. Is
It
it
goes
going to 0?
no, it goes negative.
Goes to negative infinity. And then it's the same thing. You put your finger on the curve and you say, okay, I'm going left, I'm going left. What are the y values? What are the y values?
0.
Good. All right, one more of these. And
Then we got I think a word problem. That can
yes. All right.
Mm,
So T-chart again, pretty much standard stuff here. We got x, and then we've got f of x, which is really y. So that's -2, -1, 0, 1, and 2. This time, none of the values work out nicely, so you're going to have to use decimal approximations for all of them. So go ahead and grab your calculator and
okay.
let me know what you come up with.
Mhm. Okay, so for negative, oops, I wrote negative. -2, it's gonna be 0.135.
I believe you've got maybe you don't have it in the parentheses.
Oh, yeah, hold on. I think I forgot the +3. Okay, now it's gonna be 2.718.
Okay, keep going. Doing great.
For -1, it's gonna be 7.389.
Okay, keep going.
For 0, it's gonna be 20.085. With 1, it's gonna be 54.598. And
Okay,
lastly, for 2, it's gonna be 148.413.
good. Okay, fantastic. Now, you can see the numbers get large pretty quickly.
Yeah.
Go ahead and graph this, please. Make sure you have the exponent x in parentheses with the 3.
Okay. Okay, it's graphed.
All right, do you see something that looks like this?
Yep.
Yes, okay. Now, there's nothing that's being added to it again, +0. That's the horizontal asymptote, y equals 0.
Hmm.
Go ahead and give me the domain and the range, please.
Okay. Domain is negative infinity to positive infinity. So
Good.
negative infinity, comma, infinity. In the range, it's going to be negative infinity to. Hold on, I forgot the acetone. Okay, there we go. It's
This
gonna
one's different than the last one, so maybe.
Well, it starts first with negative infinity, but it doesn't stop at 0.
So think about the y values.
Yeah.
So if what you said is true, then the graph could take on a y value of like -8.
Yeah.
Do you ever see the graph down here at -8 or -1 or -2?
No, so this time it would be positive infinity to or something.
Well, you got to think about what is the minimum y value? What is the smallest y value that you see? What is the y value approach here?
It approaches 0.
0. So that's the smallest one. Then what happens to the y values? What do you see in your table here? Is it growing or getting negative?
It's growing. So this time it would be 0, comma, positive infinity.
Yes, yes, good.
Okay.
Really good. Okay. Next one is the intercepts. Okay, so the x-intercept is when y equals 0. There is no x-intercepts. Sorry, we're doing y-intercepts only. Y-intercepts is when x equals 0, and you have it from your table. It's 0, 20.085. All right, and then asymptotes. We already kind of addressed that, but there's only a horizontal asymptote. It's when y equals 0.
Uh-huh.
Okay, and then last thing we can do here is end behavior. And again, you trace the curve or you traverse the curve. You go, okay, I'm going to the right. I'm going to the right. What happens to the y values?
They become bigger and bigger.
Okay, and what do we call that when it's getting bigger and bigger?
Positive infinity.
Positive infinity. Fantastic. Then we go the other direction. We say, okay, what if we go to negative infinity? What if we go to the left? What if the graph goes to the left?
And it's becoming 0.
F of x becomes 0. You got it.
Okay. All right. So that means we're ready for number 10.
Yes. It's a number 10. It says refer to the example 4. So I'm going to go up and grab example 4. Content on about bacterial growth. That was bacterial growth. What is the end behavior? So we need the end behavior. Explain what this means in the real life situation. Is there an asymptote? Why or why not? How many bacteria are present on Monday noon? How can you determine that from the graph? Okay, a lot of questions, but they're actually questions we've already answered in the ones that we've been doing. So it looks worse than it is. I mean, like probably many problems. Let's take a look here. Here is the example. It says a colony of bacteria has a population of 3,000 at noon on Monday. During the next week, the colony's population doubles every day, and we don't need the rest of this. This is the graph.
All right.
Okay, so what I'd like you to do first is to graph this. And you likely will not see the graph. You'll have to change your window. You can either zoom out or hit that wrench in the top right. And we can talk about how to do that, but go ahead and graph this and see if you can maybe see the shape of this thing.
Okay. That's a very nice curve, I guess, but it doesn't even go to the x, then the y axis.
It should look something like this.
Yeah.
Okay, and that value up there, we'll get to that in a moment. This is a rough sketch, but it grows. It's a growth model. Okay, so the first question that it's asking you, let me call that A. What is the end behavior for the bacteria? So we would say as x goes to infinity, so as you traverse the curve to the right, what happens to the y values?
The y value get bigger. No, wait, the x, it would get smaller.
I'm sorry, I didn't hear you. What happens to the y values? You could just, yeah, it sounds like you're a little bit far away from your headset or microphone, but it does go to,
I said that it becomes positive infinity.
yes, there it is. I can hear you perfectly now. Fantastic. Yes. And so you might even add some words that it grows forever, which could be bad. I mean, some bacteria are good, some bacteria are bad, but it just gets,
Sorry, what?
oh, I just was just saying that it does grow forever in this case, which we don't know what kind of bacteria it is, so we don't know if it's good or bad.
Mhm.
Okay, so that's getting to the part B. Okay, um, and the what does this mean in the real life situation? You might say, for example, a virus, this would be bad, right? But there's good bacteria like inside of our stomachs and our intestines that help us with digestion and things like that. That's good bacteria that we need. So, it kind of depends on the situation.
Mhm. And now for number 10, so since they're an asymptote.
Yeah, so there is when you look at the graph, but there's not when you look at the physical situation because we only consider x to be greater than or equal to 0. So we actually exclude everything here
Mhm.
because you don't go backwards. Okay, so that's why there's an explain why or why not. You would say for part C, no, the equation has a horizontal asymptote y equals 0, but the physical situation does not.
Mhm.
And you might add because the domain is x or greater than or equal to 0, or you can say from 0 to infinity.
All right, just give me 1 second, please. Okay.
All right, so part D is this question about how many bacteria were present on Monday at noon. If you go back to the original problem, it says a colony of bacteria has a population of 3,000 at noon on Monday. So that's the starting point. They're saying it's 0, 3,000 is your starting point. So there were 3,000 bacteria Monday at noon. And then when it asks, well, how can you determine this from the graph? This is the y-intercept. It's when x equals 0.
Right. All right, I'm caught up on that. You were
All right.
technically well, just finishing the last three like questions made us like done for today, basically.
Yeah, let's take a look and see what the next assignment is so that we can get a better feel for where you're at. Maybe we can get one or two problems done. We'll see. All right, looks like I gotta reload here. There we go. So we're up to exponential and logarithms. Logarithms. Okay. All right. Trying to get to the problem set here. Okay. All right, let's do number one here in your next assignment. This probably won't make any sense, but we'll just do it. And when you read about it before the next lesson, maybe it'll be a little better. So unfortunately, I got to give you the answer. Log base 7 of 49 equals 2, and then draw some arrows so you can see where these things come from. So the 2 goes there, the 7 goes there, and the 49 goes there. So this is the answer, what I've written, and you might want to show the arrows to indicate that's where the value come from.
Mhm. Got it.
And then the next problem is really similar. You just have to follow the same mapping of where the numbers go. So usually you get a couple of these, then you got it down. So if we just use the same mapping, the 10, the 10 becomes the base of the logarithm. The other number, 1 over 100, is the thing you're taking the logarithm of, and then it equals the other exponent, or the exponent there.
Mm-hmm. Okay.
So if you have time, definitely look at the lesson and maybe try the next two stop and think questions on your own before we next meet. I'll talk to Dad and figure out schedule for next week. It sounds like we might have to make some modifications, which is fine with me. So I think that'll do it for today. I'm gonna go ahead and